Welcome again for the cybercrime investigation course. This session is about acquiring evidence in a computer forensic lab, and in the past session, we were actually dealing with how to handle forensic or how to handle forensic hardware in the first session related with this week, but now we are proceeding to the acquiring evidence in a computer forensic lab, which is very important part of this class. In this session, we are going to review some of the important subjects related with acquiring evidence. And the first thing that we are going to talk about is the requirements for a certified computer forensics laboratory and best practices for managing and processing evidence in a computer forensic laboratory, structuring a computer forensic laboratory, which is an expensive process, and computer forensics laboratory requirements for hardware and software and other important information will be shared in this week's session. Digital evidence actually very important aspect of criminal investigations, where any type of criminal investigation may actually need to resort to finding digital evidence. Evidence can only be brought to trial if it was legally obtained using a search warrant approved by a court, magistrate, or a judge, or if appropriate, consent to search was granted. So what this means is that there are certain procedures that the investigator needs to follow and needs to be these procedures are to be approved by the court, or a search warrant is actually needed. Because forensic is a science, the process by which the evidence was acquired must be repeatable. What this means by repeatable is that the forensic examiner should or must be able to reconstruct the crime scene in terms of the digital evidence, where the hardware and software can be gathered, and the criminal event can be actually repeated in front of the court. And all of these procedures needs to give the same results. So the changing results may result in the failure of representing the evidence. Acquiring evidence in a computer forensic lab is a big challenge, but thanks to the new developments in the software industry, and many trainings and certificate programs allow the forensic examiners properly handle and acquire the digital evidence. The creation of a computer forensic laboratory with all the necessary equipment is an important part of evidence handling, acquisition, and analysis. Although notable differences might exist between one computer forensic laboratory and another, there are still similarities in basic requirements and guidelines for forensic laboratories. This ensures that certain standards actually are maintained in terms of equipment and industry standards for utilizing that equipment. What this means is that the tools that have been used for forensic examination, for acquiring the evidence or handling the evidence, are or have become mostly standard. So you cannot just come with a brand new and present to the court that says this works very well. But if you really want to prove your point, and the software and the tools, you actually have to prove it in a scientific manner, which would be a challenge. But the judicial system in the United States has become more experienced along the years, especially in the last 2 decades. So they also have some knowledge about the computer forensics processes. And standard practices, as I mentioned, do exist and are assessed and certified by an independent body known as the American Society of Crime Laboratory Directors. So there is an actually accreditation and certification process for the forensic labs. So they're not totally independent. It just doesn't depend solely on the experience, but there are some standards for forensic labs that they need to follow. The American Society of Crime Laboratory Directors' purpose is to foster professional interests, assist the development of laboratory management principles and techniques, acquire, preserve, and disseminate forensic-based information, and improve communication among crime laboratory directors. ACLD is a non-profit organization that provides a set of guidelines and standards for forensic labs. ASCLD is not an accrediting body and should not be confused with ASCLD/lab. So this is important to understand, as this organization is actually responsible for fostering professional interests. ASCLD lab actually was originally a committee with ASCLD when it was created in 1981, and in 1984 ASCLD lab became a separate non-profit entity with its own board of directors. So this is when they were separated. Since 1982, it has been accrediting crime labs and currently certifies labs for federal, state, and local agencies, as well as some crime labs based outside of the United States. The certification process of crime labs include computer forensic labs. ACLD lab strives to maintain certain standards for forensic labs, including standards that govern the behavior and practices of lab employees and also their managers. ACLD lab also promotes a code of ethics for lab staff and management, which are also very important for managing the lab, as if there's no ethics in the lab, then there's not going to be management and respect to the digital evidence. Laboratory managers are advised to act with integrity and create an environment of trust and honesty in the lab environment. The forensic laboratory should have quality controls and maximize the use of technology and technological resources. Moreover, the laboratory manager is also responsible and accountable for maintaining the health and safety of those who work in the lab. So these health and safety issues are quite important as the first objective of a criminal investigation in terms of actually forensic investigation is to protect the evidence. Unless you protect the evidence and also the employees who deal with the evidence, you're not going to provide a thorough investigation. ISO IEC 17025 provides general requirements for the competence of testing and calibration of laboratories, and these international standards can apply to any type of laboratory that carries out calibration and testing activities, which also includes digital forensic laboratories. These standards have been primarily adopted by traditional scientific laboratories, so they have a long, actually, history and experience and requirements. And the other institution that's very important for you to understand and also find a resource uh, accordingly is the Scientific Working Group on Digital Evidence. This is a very important organization. The committee dedicated to sharing research and setting standards for investigators working with digital and multimedia. And actually, they subsequently began working with SWGDE Lab in 2000, and federal, state, and local law enforcement officers who do not have any commercial interests are invited to join as regular members. And additionally, educators and those from the private sector can also join as associate members for this organization. Computer forensics labs exist in the private sector for many reasons. Sometimes a lab is developed to make a profit through client consulting services. And large organizations maintain labs to investigate internal fraud or fraud suffered by their customers. And banks and credit card companies often have their own internal computer forensics practitioners. And all major accounting firms maintain sophisticated computer forensic laboratories that are primarily used to support investigations requested by their clients. So in the private sector, computer forensics has a large space where many private companies need to have the actually processing of the evidence. E-discovery is another important part of the criminal investigations or subject of a civil investigation. Most of these investigations are not actually criminal investigations regarding e-discovery, but they are considered as an electronic investigations. E-discovery is the detection of electronic data for the purposes of litigation. For example, when a company sues another company, the plaintiff may request certain electronically stored information. Electronically stored information can include email, Word documents, spreadsheets, pictures, databases, and many files on a computer where actually, rather than forensic imaging, uh, more basic tools with advanced search capabilities and storing functions are actually used in e-discovery so that the uh, two sides, for example, in a civil investigation, present their evidences and then agree on the uh, agree on the legal situations and whether they want to actually sue the other side before an agreement and show the evidence to each side so that each side are aware of the consequences of the digital evidence regarding the civil investigations. The Sarbanes-Oxley Act of 2002, which President Bush signed into law, represents an ambitious effort by Congress to address many data retention and preservation issues arising from the Enron and Arthur Andersen debacles. This act is actually passed to help protect investors from fraudulent financial reporting by corporations. Publicly traded companies actually must maintain all electronic information for a specified period of time, and retention times for documents are actually dependent upon the type of the document and the industry. US companies that handle personal data for European citizens must also comply with the data retention rules embodied in the General Data Protection Regulation. Securities Exchange Commission actually is protecting investors, maintaining fair, orderly, and efficient markets, and facilitating capital formation for the United States, for the US. And actually, sometimes this commission sends a 10-day notice to a publicly traded company. The purpose of these notices are to direct a company to produce certain documents pertaining to an investigation within 10 days. So 10 days sometimes for a large company is actually very hard to collect the information properly and bring the information to the commission. But actually, many companies employ the services will employ the services of accounting firms to quickly find the information requested by the Securities Exchange Commission's investigators. There are four major issues pertaining to or related with the private companies' computer forensic laboratories. They are first, evidence acquisition, email preparation, inventory control, and web hosting. Private companies' forensic laboratories responsible for evidence acquisition, and they are also responsible for extracting evidence from hard drives, flash drives, and other storage devices to create read-only forensic image files. So keep in mind that forensic image files are read-only and they cannot be altered. The staff members in these laboratories needs to be skilled in imaging software such as FTK, Imager, and NKs, and also X-rays. Additionally, they will often have to crack passwords using tools like Access Data's password recovery kit. The most important type of evidence that can be retrieved from a computer is actually email as a digital evidence. It often reveals our most most thoughts and most actually incriminating evidence. Staff who are responsible for actually bringing the email evidence, parse the email files to make them easier to view by attorneys involved in a case. Sometimes computer forensic investigations involve thousands of hard drive and storage media. And the sources can actually vary greatly from magnetic types to hard disk drives to the thumb drives. So you might have to deal with thousands of evidence, and the inventory control in a computer forensic lab becomes a highly important part of the management of the laboratory. Therefore, a laboratory information management system is actually needed, and there are some examples of forensic laboratory information management systems where you can find some examples in your textbook, and you can also find them through Googling or using some other search engines. Web hosting is another part of the laboratory. Once evidence has been extracted and analyzed and passed into a readable format, it needs to be made available to a company's lawyers. So web hosting is one of the options to provide this actually opportunity to a company's lawyers. Simply emailing the evidence to a legal counsel is often not feasible. A computer forensics department or consulting firm may provide a web hosting device that authorized individuals can access the evidence for an investigation through a secure website. Computer forensics laboratory requirements depends on the need for the personnel or staff and who will be involved in the investigations and the resources that are available for the forensic laboratory. So there's no exact number, but depending on the need for the laboratory and the resources, the shape of the laboratory in terms of the number of seats and the number of workstations and the closet needed and also evidence locker needed. Actually, their numbers can vary. So the layout of your laboratory will be determined by your investigative needs. The workstations in a computer forensic laboratory are used for investigators to acquire evidence in the form of read-only image files. It's now more commonplace to find Macintosh workstations as well as Windows-based workstations. All workstations should be password protected and should ideally actually biometric authentication is actually should be required to gain access. And also another feature of forensic workstation is that it it ha actually has to have a strong processor. More volatile memory and large storage space is also another expectation because of indexing and necessary database storage. So all forensic workstations should have advanced capacity, and the use of actually regular computers uh, uh, is is actually not sufficient to deal with a huge number of digital evidence, and the advanced computational capacity is also required for the forensic investigation units workstations where the software actually uses different methods to actually retrieve the data in your service. Another thing that's needed for a forensic laboratory is a mobile device examination workbench. Generally, every investigation today involves at least one smartphone. As we all use smartphone, it's very likely that the forensic lab has to deal with the mobile digital evidence. More invasive techniques are required to deal with mobile smartphones due to their encryption capabilities, and maintaining a workbench for investigators to dismantle mobile devices and perform soldering with the aid of microscope is important. So there are more advanced techniques to deal with the encryption, which you can find these techniques in your textbook. Another thing that's needed is an evidence locker. An evidence locker is a metal cabinet with individual compartments that can be locked individually. These cabinets are often made of steel with temporary resistance padlocks. A high-end door lock, like a simplex lock, should be used with other physical security measures to protect the digital evidence. And at least two large cabinets are needed. First one is needed to store reference materials such as laboratory operating procedures, legal reference materials, and standard operating procedures. And also, a second cabinet can be used to store the forensic equipment. There are quite a number of hardware to deal with the digital evidence. They're actually developed by well-respected companies and specialized people or scientists have actually contributed to the development of such forensic software and hardware. Every computer forensic laboratory should have a forensic disk duplicator. You may also find an example video on your Blackboard for this week that shows how a forensic disk duplicator can be used. For forensically cloning hard disk drives at the crime scene or in the laboratory, we actually need special hardware to collect the image or to clone the hard disk drives. Many different types of hard disk duplicators exist, and they generally provide a feature to sanitize a harvest drive with an important process in preparing for an investigation. So keep in mind that the hard drives are always required to be sanitized before starting the investigation. However, purchasing a disk cloner, the purveyor should ensure that the device is actually a forensic device. Write blocker is a hardware device that follows an individual to read data from a device such as hard drive without writing to that device. So there is a risk of writing to a hard drive if you just simply try or directly try to image the source or evidence from another computer or storage. So there is a need for a write blocker to prevent writing to an evidence hard drive. In general, write blocking kit will include a number of different write blockers, power adapters, and cables which will connect to several devices such as eSATA, IDE, serial attaches, SCSI, USB, and FireWire devices. Cellular telephones that operate on the global system for mobile communications network contain subscriber identity module, SIM card, which will need to be forensically examined using a SIM card reader. So a forensic lab also needs a SIM card reader to actually acquire the information from the SIM card. Harvest drives, another important requirement for a computer forensic lab. Harvest drives are hard disk drives that act as receptacles for evidence acquired from a suspect's hard disk drive. A computer forensic lab often uses thousands of SATA drives, hard drives annually, and in most cases, two copies of each of the suspects of hard drive are required, and the same types of SATA hard disk drives can be used to clone the hard disk drives of both Macintosh Macs and personal computers. An investigator's notes are key to effectively documenting an investigation. So the investigator needs to effectively describe the crime scene in terms of the devices. Photographing devices that are seized is critical to properly documenting an investigation. An investigator should take photographs of where the devices are located and the configuration of devices or how they are connected should be also photographed. The investigator may need to recreate a number of devices that were connected, especially with an unusual setup that is unfamiliar to the investigator. So the system might be very complex, and the complexity of the system can only be reconstructed easily when the system is already photographed by the investigator. So when photographing a computer, the investigator must photograph the computer, its drive base, such as CD and DVD ROMs, ports, and the serial number of the computer, which are quite important parts of the investigation to prove that the uh, crime scene or the scene related with the investigation uh, is actually photographed completely. Evidence bags come in many shapes and sizes. They all serve the same purpose: to prevent tampering evidence and to record the chain of custody. Anti-static polyethylene evidence bags are designed to protect electronic devices from actually static electricity, and a computer forensic examiner should always have these when going outside, as the major task of a computer forensic examiner is to protect the integrity of the evidence. If you lose the integrity of the evidence and tamper with the evidence and cause the loss of data on the evidence, this could lead to a lot of problem for the law enforcement agency or computer forensic lab. So that's important. It's important to protect the evidence through use of appropriate evidence bags. The laboratory should have computers running Windows and Mac operating systems. A laboratory not only needs bit streaming imaging tools, but also the password cracking software and two software tools and MD5 program for evidence verification, antivirus software to protect your computer from viruses, and virtual machine software. A combination of imaging tools is ideal because of each tool has its own strengths in terms of recognizing partitions, the type and number of files recovered, filtering, and decryption. There are many forensic imaging and analysis tools, and some of them are more prominent, and some of them provide different features and different advantages for the forensic investigation. So it's worth to mention these forensic imaging and analysis tools. Brian Carrier has developed most of the code in the SleuthKit Autopsy 1 and 2. The SleuthKit is an open source computer forensic tool that's comprised of a group of command line tools. The tool allows an investigator to examine files in a hard disk drive volume. This tool supports many types of file system, which is a big advantage for the forensic investigator. And also this tool actually supports raw DD image, in which you can find the raw DD image exercise on the blackboard. Autopsy is a graphical user interface that is used in conjunction with the SleuthKit. So these tools work together, and these tools also can be used on either Windows or on Unix system. So I suggest you studying these tools, and actually there are many documents regarding these tools, and in the future classes we will actually practice with this tool as well. X-Phase Forensics is a valid, recognized forensic imaging tool, and it supports numerous file systems, which is a great advantage for a forensic investigator. The tool has a particularly effective file filtering feature, which is important for analyzing hundreds of thousands of files, and many forensic examiners, also use X-Phase forensic tool. Forensic Toolkit, or let's say FTK, is a bitstream imaging and analysis software produced by Access Data. The software has been well documented in many countries, court trials, including the Scott Peterson murder trial. The full version of SDK is not actually free, but it has many other features, including comprehensive reporting, file decryption, and file carving. File carving is the process of identifying a file by certain characteristics like a file header or further, rather than by the file extension or made at uh, metadata. For example, a suspect could try to hide image uh, from investigators by changing the file extension of the picture from JPEG to something else. When you or another person or examiner directly tries to open the file, then it's not going to respond to the examiner, as the operating system will not open the file. But the tools, the software like the FTK can easily help you carve the file and open the file, even if the extension of the file is different. Let's be more specific on the file carving. File carving is the process of identifying a file by certain characteristics like a file header or further, rather than by the file extension of the file, as the file extensions can be easily changed. For example, a suspect could try to hide image from investigators by changing the file extension of the picture from JPEG to DLL. When conducting a search using File Explorer, you will not be able to actually find the file as a JPEG, and also you will not be directly able to open the file. Identifying and recovering files based on analysis of file format is known as file carving. The customers of NKs requested that OpenText create special add-on programs and script as a programming language that will allow NK's users to create their own customized functions and features in the forensic examination software of NKs. And there are numerous websites where NK's users make their script and case scripts freely available to others, that increase the functioning and ability to investigate the files on a computer at a more advanced level. So this is a great advanced feature for the NCASE software. Investigators need to use virtual machine software in an investigation, especially if they think there could be a malware on a suspect's machine or malwares. A virtual machine is a computer running software that allows for an instance of an operating system or multiple operating systems without making any changes to the user's computer. So not only virtual machine softwares protect your computers, they also allow you to use multiple operating systems at the same computer, which gives a very big advantage in terms of lowering the costs of accessing to different operating systems. After the user terminates a virtual machine session, the computer's configuration remains unchanged. If a criminal uses virtual machine software to perpetrate criminal activities, this makes the work of the computer forensic examiner much more difficult as little or no evidence relating to the suspect's activities then can be found on the computer. So this is a big challenge for the computer forensic examiners. VMware is well-known virtual machine software that an investigator can use to reverse engineer malware. The software is ideal for examining malware because the investigator's computer settings will remain unaffected by the malware. Examining the malware code is helpful as the programming code for viruses can be compared to identify whether the malware code found on the victim's computer was authored actually by the same hacker. Additionally, the virus's code may include the IP address of the hacker's computer, which was used for command and control. So reverse engineering malware can be extremely helpful. Reverse engineering malwares can be extremely helpful in solving cyber crimes. VirtualBox is similar to VMware, and it supports the creation and management of guest virtual machines running Windows, Linux, BSD, and many other operating systems. Another thing that's very important for a computer forensic lab is to own a password cracking software. A computer forensic examiner commonly encounters computers that are password protected. The entire system may require a password to access the desktop files and folders. A separate password may be actually required for administrator access, which allows for certain access right, like installing software. So you need to be able to crack the software in certain cases. And password recovery toolkit is a well-known toolkit, and access data's fee-based version of the SDK comes with a tool called Password Recovery Toolkit. Many law enforcement agencies purchased Rainbow tool tables that contain thousands of or even millions of different hash values that are used to crack the passwords. So the hash values are the ones that you need to uh, utilize to crack the passwords of applications or computers. Another notable password cracking tool includes John the Ripper and Cain and Abel, and these tools are well-known tools. The other thing is the budget of the computer forensic lab. Developing a fully functional crime laboratory is actually expensive for many local law enforcement agencies, and it's also cost prohibitive. This is why the growth of regional computer forensic labs across the United States managed by the FBI and staffed by local law enforcement has become so important. In 2011, RCFL was opened in Orange County, Florida, in Orange County, California, at a cost of $7 million. The security of the computer forensic laboratory is quite important as if you do not secure the lab, then you're not gonna do your job. So an audit of those who has access to the computer forensic laboratory is necessary. And also automatically recording who enters the laboratory is also necessary. So the entrance to the lab should be done via identification cards or cards, and also a sign-in sheet also has to be in the lab, that every person that enters the lab, including the timing and the timeout and approval signature, actually should be uh, completed. And the computer forensic lab needs to be in a secure area, and the evidence files should be backed up every night on the laboratory's servers. So backing up the evidence is also an important matter, as the hard drives can wear and you may lose the information or the evidence files on the servers. Investigators use three primary methods to extract evidence from a device. The first one is by means of using a hardware device, uh, such as a hard disk drive duplicator. And also the second method is using software such as FDK and NCase, and also using line command interface. This third method involves running Linux commands, but to acquire evidence and to search and filter evidence using the Linux commands can be very helpful. DD is a Unix command line utility used to copy data from a source location to a destination for a computer forensic perspective. DD is important because it's an accepted file format for forensic imaging and because of its versatility. DD is versatile because it can be used to image very specific data. And the user can verify image by using the MD5 algorithm, and image can be sourced from a specific computer on a network, and that image sent to a network location. The format of the DD utility is as shown in this example, and you need to type in DD on a Linux machine and write if and then the source, which is a short for the input file, and then write the destination short for the output file, which means you may direct the output to a USB drive or flash drive, any type of drive, and the byte size of the each files actually collected in 412 bytes, and each chunks are actually uh, uh, collected from a computer 512 bytes by 512 bytes. Unix and Linux commands can be used to extract evidence from a device. And the Linux operating system is typically free. The DD utility can copy data from a source location to a destination. The DD utility is an accepted file format for forensic imaging. Global Regular Expression Print grep is a utility used to extract data using pattern matching, and this is available on Linux operating systems. Uh, Extended Global Regular Expression Print allows for use of operators not found in basic grep. And fast Global Regular Expression Print interprets characters literally and is faster than grep. So it's always important to understand the use of grep, as it provides greater opportunity for investigators to find files that have specific features. Using grep is very useful to find financial fraud. And credit card numbering systems using the major industry identifier help determine some industry categories. So you need to know the credit card numbering system And here is an example when a credit card number actually starts with 4, then that's a Visa card. The type is changed. And if the number starts with number 5, then the card is a MasterCard. So this helps you investigate and find certain types of credit card numbers or certain credit cards. The first 6 to 8 digits on a payment card, such as credit card or debit card, are known as the issuer identification number. It's also known as bank identification number. The IIN is only used to identify the card network, not actually the card holder. So here you are seeing the IIN range of the card numbers, which starts and which is actually between, let's say, 51 to 54, and this helps you identify the card network, and also you have the opportunity to understand that the card has only 16 digits, and some cards can have more digits, so that's why we are including the number of digits here. A skimmer is an electronic device used to capture data from the magnetic stripe on a debit card or prepaid card. These devices are often examined in a computer forensics laboratory, and skimmers have reached epidemic proportions and are used by identity thieves worldwide. So this is a very common device, and these devices are available online, which is easy to purchase these skimmer devices, and there are various types of skimmer devices sold online. Not these types of are actually customized by actually the users to use or to use in bank ATM. So there are ATM fake cards, slots overlays, and with skimmer device, these devices can be very harmful, and they can collect thousands of credit card information from a central location. Skimmers are generally battery operated, and although they are illegal in the United States, they can be easily purchased in Canada or on the internet. An ATM skimmer is used to capture data from the magnetic stripe on credit cards or ATM cards. The ATM has a false front to capture this data. That's how they work. They collect the data from the false front. And here in this exercise, we are gonna do forensic imaging in this lab too. You're expected to do the assignment as in this practice. You'll need to have a USB flash drive for imaging. The purpose of this assignment is to take the image of a USB flash drive using the FTK imager. In order to do so, you first need to insert your flash drive. I suggest you find a small size flash drive in order to take the image of it, because it may take longer for your computer to take the image of a larger USB flash drive. And then in the next step, after you open the Access Data FTK imager, the first thing you need to do is to click on the File menu and click Create Disk Image, and then directly choose, if not chosen, the physical drive, and then click Next, and then from the source drive selection, this is the source drive that you are selecting actually, in which the flash drive is the drive that you want to bit by bit copy the information and data inside the flash drive. And then click finish. And when you click finish, actually you need to click add, and there are four different types of images here. We are going to choose raw DD image in this assignment, and there are other types of image types that we're not gonna practice in this assignment. For example, E01 is NCASE. NCASE is another forensic analysis software which has an E01 extension. We are not going to use this or the others for this assignment. We are going to just click to raw DD image type and then click next. And you're expected to enter a case number. Let's say this is our first case number 0001, and then this is the evidence number related with the case. This is also, let's say, 001, and unique description USB evidence for phishing. USB evidence, let's just say USB evidence for phishing, and examiner is your name, and then you can take some notes from here, and you just need to click next. And in the image destination folder, this is where you want to actually copy the image file on your either on your computer or either onto another hard drive that's external, or you can also even copy the image of this file in a network computer or server. So let's say I know where I want to actually copy the image file, as I already created an evidence folder and also a case folder on my computer's C drive, so everything is ready. But if you want to create, or if you just want to browse the file and folder from here, you can do it like in other cases as you do to find a folder or file in your computer. So here we need to write an image file, let's say USB image case 1. This is how I want to name the file. This is a little bit of a longer file name. Anyway, the image fragment size is usually chosen 1500, and this is actually a standard way of defining the chunks of data that needs to be actually divided when your copy of image is actually located or copied on your computer's evidence folder and case folder actually. After all, you just need to click finish. When you click finish, everything is almost ready. Here what you are seeing is that verify image after they are created. This is important. You need to check this actually checkbox as you want to verify the image with MD5 and SH1 algorithms, and then just click start. When you click start, it's gonna start copying the image of the USB file bitban USB drives information bit by bit. So in this case, it's gonna take some time. I'm assuming it'll be like 10 to 15 minutes for the smaller 4 GB flash drive, but yours may take longer. And after the image taking finishes, you're gonna see MD5 and SH1, SHA1 values. So you are gonna see two values, and I expect you to copy these values on your Word file or whatever the Office program that you are using as an outcome of your practice. And also, I suggest you to take some notes when you are implementing this exercise. And if when you feel needed, you are just expected to share your experience with your classmates in the discussion forum. Thank you all. We are going to continue with this presentation. When the processing of the image finishes, actually FTK will show you a result page with MD5 hash and SHA1 hash that actually you can copy from here and then close the page, and then you are done. And after actually FTK finish all the work in the next step, you're supposed to check the files created by the Access Data FTK imager. When you actually open the folder, evidence folder that you created on your computer, you'll see different files. When you look at the files here, the file size is 1,536,000 kilobytes for each of the 001 file types. And you can also find more information about the imaging process on the TXT file. When you actually click the USB image case TXT file, what you'll see is the case number and evidence number that you assigned, and the examiner's name, and also technical information about the source item that we actually already a little bit of mentioned about cylinders, tracks, and sectors regarding the hard disk drives, and more information about the USB device, including the drive serial number and drive interface type, which is USB. And is this a removable drive? Yes, it is. And you will also see the MD5 checksum and SH1 checksum here. This is the confirmation of your actually imaging with a hash value, which is important, and more information can also be collected from here, where the accusation and when the accusation started and finish it, and also the name of the files for the acquiring of evidence. And image verification results are also important, and which shows that the image actually verified with the FTK and produced the same MD5 checksum, which means that the evidence has not been or not tampered by any means. Thank you all for participating in this exercise and following this presentation. Have a good weekend.